to learn about the Byzantine Generals Problem. So this problem is a generalized version of the two generals problem. So here a group of army generals are planning to attack or retreat a city. So here the only way of communication between them is the passing messenger between the army generals, and they need to agree to attack at the same time in order to win the city. So the issue is that one or more generals can be a traitors and can communicate a misleading message. So here 4 army generals, so 1 commander and 3 army generals are there. So all 4 of them must attack the city at the same time. If even one of the general refuses to attack and the remaining 3 attack the city, then they cannot win. And here the only way that they communicate with each other is by passing a messenger. So here there is no communication signals, so they have to pass the message only by the messengers. So here the main problem is that one of the general may be a traitor. So here the traitor will always send a misleading message to the remaining army generals, and he will confuse the remaining army generals to whether to attack or retreat the city. See, in the Byzantine Generals Problem, there are 1 commander and 3 generals. So here the commander will send a message to all the generals to attack the city. So here all the army people must attack the city at the same time. So for that time, the generals will start communicating with each other. So here there is this one traitor, that is this person. So he is a traitor. So now the commander will send a message to all the generals. So if you consider this general, he got 2 attack messages. So one is from commander and one is from general, and 1 retreat message from the traitor. Okay. So here also this general got 2 attack messages and 1 retreat message. If suppose they believed in this traitor words, and if they stopped attacking the city, then the commander only will attack the city and he will be killed, because only 1 person has attacked the city here, right? So all the soldiers must attack the city at once, but here only the commander will go and attack the city and he will be killed. So that's why to solve this Byzantine Generals Problem, each general will consider the message with majority. So here a general is getting 2 attack messages and 1 retreat message. Similarly, this general is getting 2 attack messages and 1 retreat message. So he will consider the majority, that is the attack, and all the generals will attack the city at once and they will win the city. If suppose there are 2 generals who are traitors, then what will happen? These generals will send a retreat message to the remaining soldiers. So here the commander has ordered to attack the city, but the generals are sending the message retreat to the remaining generals. Suppose you consider this general scenario. So here he got 1 attack message and 2 retreat messages here. So now the general will consider so that they are not attacking the city, and he will retreat. Okay, so here he got 1 attack and 2 retreat messages. So that's why this general won't attack the city, and this traitor also won't attack the city. Now only the commander will attack the city, because the general is considering the majority. So here the majority is retreat and only 1 attack is there. So in order to solve the Byzantine Generals Problem, so we are having a small formula here. So here all the generals must agree on some protocol. So agreement between the generals, even in the presence of malicious generals, that is traitors. so that the attack can still take place at the same time. So all the generals must attack on some protocol that in a particular time they have to attack the city. Then only, even though there is a traitor, they can attack the city at once. So in the Byzantine Generals Problem, so we are having a formula that is f less than or equals to n minus 1 by 3. So this problem arises in the distributed system. Okay. So in the Byzantine Generals Problem or Byzantine fault tolerance, so if f is the number of faulty nodes, then 2f plus 1 non-faulty nodes are required. That is f less than or equals to n minus 1 by 3. So f is the faulty node, that means the person who is a traitor, and 2f plus 1 is a non-faulty node, that means the remaining generals, army generals. So faulty nodes means a traitor and the generals. So you may got a doubt that why we are considering this generals problem for the distributed systems. So generals can be considered as nodes and traitors can be considered as a Byzantine or malicious nodes, and the messenger can be thought of as a channel of communication between the generals. So in the generals problem, so each general is considered as a node or a computer, and the messengers as the communication channel, and the traitors as the malicious nodes, so which is sending the abnormal messages to all the nodes. So malicious means it may be hacked by someone or it is not working properly. So the first practical implementation was made with the invention of the Bitcoin, where the proof of work algorithm was developed as a mechanism to achieve the consensus. So here total there are 7 generals. In the 7 generals there are 2 traitors and the 5 generals are there and the 2 traitors are there. So from the formula of the practical Byzantine fault tolerance, so there may be f number of faulty nodes and 2f plus 1 number of non-faulty nodes, right? So here the f means there are 2 faulty nodes, 2 traitors are there, and 2f plus 1. Okay. So 4 plus, that means 2f plus 1 means total 5 number of non-faulty nodes may be present. So if this type of situation occurs, then they can reach a consensus agreement and they can follow the message and they can attack the city. If suppose, so there are 7 generals in which 3 are traitors and 4 generals are there. So in this situation, they cannot attack the city because they can't reach a consensus agreement. So they cannot reach a consensus protocol. Why? Because there are f number of faulty nodes. Here the f is 3 and 2f plus 1. That means 7 non-faulty nodes must be there. But here there are 4 number of generals, right? So there are 3 traitors and 4 generals, where we cannot reach an agreement to attack the city, right? So this is an invalid one. So we are applying the same formula here. So f number of faulty nodes and 2f plus 1 number of non-faulty nodes must be present here. So in simple manner, so there must be 2/3 of the generals and 1/3 of the traitors may be present. The traitors must be less than or equals to 1 by 3, and generals must be 2 by 3. Okay, so if in this ratio the generals and traitors are there, then only they can reach the agreement and they can attack the city. Consensus mechanisms. So consensus is the process of agreement between the distrusting nodes on a final state of the data. So in order to achieve the consensus, different algorithms can be used. It is easy to reach an agreement between two nodes. For suppose a client-server system, but when multiple nodes are participating in a distributed system and they need to agree on a single value, it becomes very difficult to achieve the consensus. So this concept of achieving consensus between multiple nodes is called distributed consensus. And having the different types of consensus mechanisms, that is agreement, termination, validity, and fault tolerant and integrity. So agreement means all the honest nodes, that means all the generals must decide on the same value to attack the city. And termination, all the honest nodes terminate execution of the consensus process and eventually reach a decision. The next one is the validity. The value agreed upon all the honest nodes must be the same as the initial value proposed by at least one honest node. And the next one is the fault tolerance. The consensus algorithm should be able to run in the presence of faulty or malicious nodes, like Byzantine nodes. The next one is the integrity. This is a requirement whereby no node makes the decision more than once. The nodes make decisions only once in a single consensus cycle. So this is about the consensus mechanisms and Byzantine fault tolerance. So here in the Byzantine fault tolerance, so it is tolerating the fault. That means it is tolerating the malicious nodes or faulty nodes, and they agree, and all the remaining nodes are based on a agreement, and they were communicating with each other in the distributed systems based on that agreement. So even though there is a faulty node, so all the nodes are agreed to a particular agreement and they were communicating with each other. Okay. So this is all about the Byzantine fault tolerance. Thanks for watching the video.